So differentiation is the process of computing a derivative. Recall, a derivative computes the 3 words. What am I looking for? Not slope, but rate of change. That's right, ROC. So far we know the definition for derivative. We're going to use h instead of delta x. It's the limit as h goes to 0 of, what's the definition of derivative? F of x plus h minus f of x all over h. Everybody should know that, yes? So if I use the definition of derivative, I would plug this in, and you found that when you had quadratic, sometimes it was really hard to find the x plus h when you substitute in there, right? So there's got to be a better way, and there is. So what's the better way? It is some of the rules coming up here. One was the power rule that I already exposed you to. Okay, so smarter people such as Isaac Newton used the definition of derivative to develop differentiation rules to considerably speed up the process. So the first rule is the derivative of a constant is 0. Why would that be the case? Yeah, a constant means the line is a horizontal line. There's no change. Does everybody see? The rate of change is 0. Yes? So by definition, a constant is not changing. That means its rate of change is 0. So what's the derivative of y equals 2? Y prime would be 0. What would y prime be for b? 0. What would y prime be for c? Do you know that pi to the power 3? Pi is not a variable. It's a constant. So it doesn't matter what it is. It doesn't matter if it's got a power. The derivative of a constant is 0. What about sine of pi over 4? Well, sine of pi over 4 is a number. A number is not a variable, so that means the derivative is 0. So that's a trick they like using, goofy constants like pi or e, thinking that it's a variable, but it's not a variable. It's just a constant. So don't get tricked by that. Yes? Rule number 2. The derivative of a simple variable with a power 1 is 1. Why is that? Think about what y equals x looks like. What does that line look like? It's that diagonal line there, right? What's the rate of change? Up 1 over 1. Do you know everywhere on this line the slope is 1? Therefore, anytime you have a derivative of one single variable to power 1, it's always 1. Recall the derivative computes the slope of a tangent line. If y equals x, a rising line with a slope of 1, then y prime equals 1 since the tangent line has a slope of 1. Pretty easy, right? Okay, so the power rule is the video we just saw. So what did we learn about the power rule there? You take the exponent and you move it in front of the variable. And then what do you do to the power? You subtract 1, so it's going to be n minus 1. So what would be the derivative of y equals x to the power 3? 3x to the power 2. Very good. How about this one? Y prime equals 5x to the power 4. What about this one? Y prime equals? Very good. So the power rule is probably the most used differentiation rule. So important tips. All radicals are simply fractional exponents. I know some of you have forgotten this, but that's okay. Remember that an n root, the n is a denominator, and whatever is inside goes on top. So convert it to, any kind of radicals, convert it to an actual power, and then use the power rule. So what would this be? Well, I would first rewrite it as x to the power 2 over 3, and then my y prime would be, the power goes in front, so it's going to be 2 over 3 x to the power. Then I have to subtract 1 from the actual exponent. Negative 1/3, very good. Now, usually we don't use negative exponents. You can keep your answer on the test and on the AP exam with negative exponents. However, the multiple choice and the answers in the back of the book might have the exponents as positive. So do you remember how to make this positive? How do you make this power positive? You make this into the denominator spot. So this would be 2 over 3x to the power 1/3, like that. The 2 over 3, the 3 was a denominator already. I'm not changing the 3. I'm just moving the x in the numerator spot to the denominator spot, and that makes that power positive now. Okay? Tip number 2, a power in the denominator can be pulled up as a negative exponent. So does everybody see, if you ever have a question where you have 1 over something to the power of something, you can bring it up and then use the power rule. So find the derivative of y equals 1 over x squared. So first step, write it as x to the power negative 2. Now find the derivative. Y prime is going to equal negative 2 x to the power negative 3. Okay, the coefficient rule. So the coefficient, all you have to do is basically let it hang out there and then deal with it after. So when you have a coefficient of some function, just like the video said, scooch the coefficient over, find the derivative, and then simplify afterwards. So for instance, this 7x squared, you put the 7, you kind of scooch it over, then you actually do the derivative of x squared. Okay? So the derivative of x squared is what? 2x, and then you just simplify afterwards. So that would be 14x. And you might say, can't I just do that directly? For sure. If you understand that the 2 is going to get multiplied by the 7 and I'm going to get 14 and then I'm going to subtract 1, you can go directly to that step. So the coefficient just gets scooched over, okay? All right. Next one. What would y prime be then? 75x to the power 4. Look how fast we can do that. What about this one? 12 pi t to the power 11. Very good. Okay, what are we supposed to do to this one here? We need to first write that on top. So we're going to rewrite this as y equals 7x to the power negative 3. Is everybody good with that? Then what I'm going to do is I'm going to compute the derivative. And what do I get there? Negative 21x to the power negative 4. Very good. And just for fun, let's make this a positive exponent. So what would my final answer be? Negative 21 over x to the power 4. Is everybody good with that? Okay, what do I do for example 9? Again, I need to move it to the top. So rewrite y equals first. So this is 7x to the power negative 1/2. Is everybody good with that part? Okay, so what's y prime going to be then? Negative 7 over 2x to the power negative 3/2. Very good. Make sure you make your exponents little superscripts and not so big that it looks like a multiply or a subtract if it's a negative. Okay, the sum rule. The sum rule. So the sum rule If an expression has two or more terms, we can compute the derivative of each term separately. And this works for addition or subtraction. So essentially, if I have this function like this, I can just compute each and every term separately. So what's the derivative of t to the power 3? 3t to the power 2. What's the derivative of plus 5t to the power 2? Plus 10t to the power 1. What's the derivative of minus t? Minus 1. Remember, the derivative of a variable is just 1. If it had a -1 coefficient, essentially, then that means it's going to be -1 times 1. And then the derivative of a constant is 0. But say you forgot that the derivative of just a variable is 1. The 1 power would go in front, and then what's 1 subtract 1? 0. What's anything to the power 0 except for 0? It's 1. Does everybody understand how I got that? That the derivative of a product is the first function derivative times the second left alone plus the first function left alone times the second derivative. So, does everybody see? This is just a nightmare to multiply out. Two trinomials together. You could multiply it out, then find the derivative using the power rule. However, using the product rule is much easier because it's much easier to find the derivative of this, right? So, y prime would then be, what's the derivative of the first function? So this is my f, and this is my g. So remember, it's f prime g plus f g prime. So what's the derivative of x to the power 3? 3x squared. What's the derivative of 2x squared? 4x. What's the derivative of 1? 0. Leave the g alone. 6x to the power 7 minus 5x minus 7. Plus, does everybody see? We're going to be adding because it tells me I need to add. Then we take the first function, leave it alone. X to the power 3 plus 2x squared plus 1. Now I'm going to find the derivative of the second function. What's the derivative of the second function? Well, what's the derivative of 6x to the power 7? 42x to the power 6. What's the derivative of minus 5x? Minus 5. What's the derivative of minus 7? 0. Done. This is my answer. You do not have to multiply it out.
Good. Good.
Be sure to put each part in brackets to properly represent multiplication. Do not multiply all of this out. Do not simplify the derivative unless the question specifically tells you to do that. Otherwise, that's so much work for nothing. Okay, let's find the derivative of this. Let's find the derivative of this. I hear 5t to the power 4 minus 3t squared, close the bracket, leave the second function alone. 3t to the power 4 plus 6t minus 8 plus, leave the first one alone. T to the power 5 minus t to the power 3. What's the derivative of 3t to the power 4? 12t cubed plus 6. Oh, I can't even fit it in there. And then minus 8 is 0, right? So we would just leave it like that. And we're done. Yes. Now, I highly recommend, I can't stress this enough, that you do it in that correct order. Why? Because the next day's quotient rule although addition doesn't matter if it's in a different order, subtraction actually does matter if it's in the right order.
So you say you want to strike P5, P2, 4, the 12.
Yeah, yeah.